All right, question 3 has been on every test. This is something they test all the time, so this is something I pay attention to even for this test this year. There's a lot of info here. We're gonna have to speed through this one to get it in under 15 minutes, but I'm gonna do my best. So, first thing to notice, this is the graph of g, and g is the derivative of f. They're gonna do this in one of two ways. They're either going to say that g is the derivative and give you the graph of g. They may just say this is the graph of f prime, which is what we have. We have the graph of g, and g is f prime. In fact, I'm going to go ahead and write that there, that this is f prime. The other way that they could do this is they could write it like this, which is going to be the exact same way here. Since g of x is equal to f prime, we could also say that, f, get rid of that f of x is equal to the integral. And so it would look just like this. F of x equals the integral of g of x, and they would give you some value here, and not necessarily a 0, and then they would put like a t here, and have you give that information that way. It says the same thing, right? So it's essential just to know that the graph is the derivative, and most of the time, that's what you have, okay? So now that we've got that kind of locked down, let's, we don't need that up there, let's just get rid of that. And then let's take a look at part A. Part A is asking us to evaluate. We're given that f of 1 is equal to 3, and we want to find f of negative 5. No problem. This is a lot of work here, but it's not too bad. It's all about f. We don't have f. We have g, and I don't want to think of that as a g. I have f prime. Get everything in one letter, not bouncing around from one letter to another. So we have the graph of f prime, and we want to talk about f. We know that that's going to be an integral. So I'm going to integrate f prime, which is the same thing as g, and so I'm going to integrate g of x, and we're going to integrate that from something to something. Now, I can pick any numbers that I want. Logically speaking, I'm going to integrate that from 1 to negative 5. Why would I do that? Well, if I integrate g, which is really just f prime, the integral of g should be f, because the g of x is f prime, and if you integrate f prime, you get f of x, plus some constant, but we have values here, so the constant doesn't matter. And so that integral will be f of negative 5 minus f of 1. So now all I need to do is figure out these things, and I'm good to go. I need to find f of negative 5, so that's going to be my variable there. I need to know f of 1, excuse me. Well, I know f of 1. They told me that right up here. F of 1 is negative 3, so I'll be able to put that there. So then the only thing I need to be able to do is integrate from 1 to negative 5 of g of x. I can totally do that. I have the graph, and so all I need to do is make sure that I'm using the appropriate values. I want to integrate from x equals negative 1 to x equals 5, and that's just going to require me to do some work with shapes. That's it. No big deal. So we're going to find that area, but I highlighted the wrong numbers. I went from 1 to positive 5, not 1 to negative 5. So we want to integrate from 1 back to negative 5. So what that's going to look like is we're going to be finding the area of this triangle right here. That'll take us from 1 to 0. From 0 to negative 1, it's 0, and so I don't have to worry about that. And then I'm just going to have to do the area of this trapezoid. No big deal at all. So the area of the triangle, 1/2 base times height. The base of this triangle is 1. The height of the triangle is 2, and so that's going to be 1/2 1 times 2, which is 1. But remember, direction, we're reading backwards, and so that area is going to be negative 1. That's the area of that triangle. Next, the trapezoid. The area of the trapezoid, that's going to be 1/2 the height times base 1 plus base 2. The bases are 4 and 3. The height is 3, and so that's going to work out to be 10.5. Because that's below the x-axis and we're reading backwards, it's going to be a positive 10.5. We're looking for f of negative 5, so I don't know what that is. Minus f of 1, I know what f of 1 is. F of 1 is negative 3. Sorry, f of 1 is positive 3. I double-checked that. That should be a plus, not a minus. So let's change that to plus. Positive 3, no big deal. And so this is going to be f of negative 5 minus just 3. No problem. From here, you can do the math, subtract that, add that over, and you should easily be able to find f of negative 5. And f of negative 5 is going to work out to be 12.5. Not too bad. relatively easy. It's the knowledge that is the biggest stumbling block. The math itself is pretty easy. As far as points are concerned, you don't get a ton. You get a point for coming up with the integrals, and then you get a point for having the final answer, and that's it. So if this was something that was challenging for you, it is only 2 points, which isn't that big of a deal. Okay, so for Part B is extremely straightforward as far as thinking is involved, just a lot of work, of doing areas. Part B is asking us simply to integrate from 1 to 6 g of x. We have the function g of x, it's right up there, and so we simply just need to find some areas. However, if I'm going to integrate from 1 to 6, let me get rid of all of this that I've marked on the picture before. Now we're integrating from 1 to 6, so that's from here to here. The first part's pretty easy. We have a trapezoid, or actually a square, that portion, and then from 3 to 6, we're going to have to actually use the function. No problem. So I'm going to break this up into 2 separate integrals. We'll integrate from 1 to 3, and then from 3 to 6 using the additivity property. They're definitely going to ask you to do something with additivity, because that's a pretty straightforward idea in calculus. So breaking this apart, and then integrating the first integral from 1 to 3, it's just a square. That's all that it is. It's space of 2 and a height of 2, and 2 times 2 is 4. That's the easy part. The other part, it's not that difficult. I just have to use the formula that they gave me for g of x, and so I'm going to integrate from 3 to 6. The formula that they gave me for that portion, that parabola, is 2 times x minus 4 quantity squared. That's what I'm going to have to integrate by hand. And so to be continued right up here, that's going to equal 4 plus, when I do that integral, it's technically substitution, but it's not that big of a deal. The integrals aren't going to be that big of a deal. They're not going to be super duper nasty. Neither are the derivatives. It's simply 2/3 times x minus 4 cubed, and we're going to evaluate that from 3 to 6. From here, I don't need to go through and do all the plugging in. You should be able to do all of that at this point. If you plug in 6, you should get 16/3. And if you plug in 3, you should get negative 2/3. And so when you put that 2/3, when you put that all together, you end up getting 10. As far as points are concerned for this part, just a few points. You get a point for knowing that you got to break them up. You get a point for integrating this portion correctly, and then you get a point for the right answer. So even if Part A wasn't too bad, was bad for you, Part B isn't that big of a deal. I can see us getting the points for Part B, even if we missed out on Part A. Now, I'm going to need some space for Part C, so let's move over to a new slide. Same pictures, taken from the same place, but let's go ahead and take a look at Part C. Part C is asking us to determine when the graph of f, let's get that in the right color, when the graph of f is both increasing and concave up. Not G, not the picture. When f is increasing and when f is concave up. So, forgetting about everything that we have, if I want to know when f is increasing, what that means for us, that means that I need f prime to be positive, greater than 0. For f to be concave up, I'm going to need f double prime to be greater than 0. And so those are the two things that we're going to need to look for. We know that this graph is the graph of g, and it says that g is the derivative of f. So I don't want to think in terms of g, I want to think in terms of f. So I'm going to forget about the fact that that says g, and I'm going to say that this is the graph of f prime. So in the blue color, we want to know when f is increasing, we want to know when f prime is greater than 0. That's when the graph is greater than 0, and we can clearly see that this graph is greater than 0 for x greater than 0. That portion right there. Keep it going. There we go. So I know that that portion, super duper easy, is going to happen when the values from x is between 0 and 6. Easy. For the second portion, we need to figure out when the graph is concave up. That's when the second derivative of f is greater than 0. Since this is the graph of f prime, we want the slope. I want to know when the slope is positive. So looking at this picture, my slope is positive from x equals -2 to x equals -1. The slope is positive from 0 to 1, and the slope is positive from 4 to 6. So if we put all of those values in there, I should have written the first one. In fact, I don't like the way I wrote that first one. Let's go ahead and erase the way that I wrote it, and let's write it the way that I would normally write it in class, in a parenthesis value. So from 0 to 6. So much better. Don't know what I was thinking. Must be the COVID. Not that I have it. I've been practicing safe distancing. You should too. So writing this out, we're going to integrate, or not integrate, excuse me, we have values from -2 to -1. If I can write on my iPad, there we go, from -2 to -1. We're also going from 0 to 1 and from 4 to 6. And so then we just got to find the overlap. This one's really easy to find the overlap. I didn't need to write this out in this fashion, but I normally do that, and so I just want to keep things normal. So the overlap just from 0 to 6 for increasing, so we'd be from 0 to 1 and from 4 to 6. We need an explanation. Our explanation is already there. We would just want to write that portion out. Due to time, I'm not going to, but that's the explanation. Write that out in words. The reason why we have these values is this is when f prime is greater than 0, and this is when f double prime is greater than 0 as well. So you want to write that out in words, but there's your explanation, and there's your answer. As far as point totals are concerned for this problem, you get 1 point for your answer and 1 point for your explanation, and that's it. But realistically, we should easily have those points. Finally, part D, let's section off this part C like that and like that. And so then part D is asking us to find the x-coordinate of every point of inflection. We'll start it down here and we'll probably carry it up over. The x-coordinate for the POIs. Well, you just go through the steps just like we've done in previous problems. How do you find a point of inflection? You need the second derivative. What is the second derivative? The second derivative is the derivative of the picture because we're talking about f. And we need to see when that second derivative, the derivative of the picture, is equal to 0. And we want to see when the second derivative does not exist. Now, this is a weird one, because the graph, when the derivative of the graph is equal to 0, is over a certain area, right? If we take a look, I'll highlight it here in, let me get rid of my highlights from the previous problem, and we're going to look at the highlight here of when the graph has a slope of 0. Well, that would be all of this time right here. It's not just at one spot. All of this time right here, all of this time right here. We can put those down, but we're never going to have a point of inflection over a range of values. So those don't really count. The only time that we have a point of inflection is if we have one spot where the derivative is 0, and the spot where the derivative is 0 is at x is equal to 4, the bottom of that parabola. So that's going to be our first and really only time we care about. We don't care about the range of values where the derivative is 0. For the derivative does not exist, you're looking for corners and cusps, things of that nature, and we have those as well. I'll put that in blue. We have a corner here at x equals -2, a corner at -1, a corner at 0, a corner at 1, a corner at 3. So we get 1, 2, 3, 4, 5 different values where the derivative does not exist. Let's get those all listed down here below. And poof, like magic, I put them there. So these are the only spots where we could possibly have a point of inflection. You can't have them at any other spot. The only way to get a point of inflection, by definition, a point of inflection is where the graph changes concavity. This is where these flat spots tend to throw us off. These flat spots, those that I've got highlighted in red, that are actual parts of the graph, so not at x equals 4, but the other spots, you're not going to have a change of concavity there, because the concavity at those 3 spots that are part of the graph where it's horizontal over a range of values is no concavity. You can't change concavity from no concavity. The change has to be from positive to negative. And so when I'm looking at these, x equals -2 can't be a point of inflection because it starts out with no concavity. Same thing here at -1, at 0, at 2, and at 3. None of those are going to be points of inflections because they all have horizontal pieces either before or after. However, at x equals +4, if you look at the slope of the graph changes. On the left side, it's decreasing, and on the right side, it's increasing. And so that's going to be where we have our only point of inflection. And so we'll go ahead and I'm going to put the answer D up here. X equals 4 is the only point of inflection. And why? Because F double prime changes signs. That's the only thing you need to say. You don't have to say why the others aren't. You just have to say why this one is. That's very, very important. And so where we get points, a point here and a point here. And there you go, super duper easy.